Hello everyone, this is chapter 6 and our fourth video of this series. This one is on upper level charts, and this is upper level charts as opposed to surface level charts. Surface level charts are at sea level at approximately 1,000 millibars, but upper level charts can be 750 millibar charts, 500 millibar charts, 300 millibar charts. Let's go over a little bit about the altitude of these charts in relationship to what we already know. For instance, you know that about 90% of the atmosphere is within the first 10 kilometers of altitude. And in fact, that 750 millibar chart will be at about 3 kilometers altitude, very, very low. And the 500 millibar chart, about 5 kilometers, 300 millibar chart, about 9 kilometers high. So we're not talking about a big chunk of the atmosphere here, but a very important part of the troposphere. In fact, the 500 millibar chart is what's called the steering level chart. It's going to be the one that we refer to most often. Pilots often refer to the jet stream level chart at 300 millibars, which is obviously higher. Let's talk about how these are developed, and we'll talk about them by using a lower chart. We'll talk about developing these upper level charts by using an 850 millibar chart. That 850 millibar chart tells you the altitude of a surface, an imaginary surface that has 850 millibars of pressure above it. Because of course we measure air pressure by everything that is above us at that altitude. Let's explain it a little bit differently. If you had cold air in here between the 1,000 millibar sea level and the 850 millibar upper level chart, you know that you would have approximately 150 millibars of dense cold air pressure in this space, in this column. Let's compare that to some very warm and less dense air that rises really well. That warm and less dense air, the same 150 millibars of pressure, would take up a much taller column. Therefore, the 850 millibar altitude would be higher with the warm air. In this specific instance, we're looking at a platform or a plane that moves from 1,800 meters of warm air down to about 1,200 meters of cold air. All right. There's another thing that impacts the altitude of the 850 millibar chart and all upper level charts, and that is latitude. And that makes sense because the southern latitudes are warmer. So they're going to put up warmer columns of air that are less dense, and that 150 millibars of pressure is going to reach up to a higher altitude as opposed to the northern latitudes. So yes, it's the temperature of the air, but it's also really modulated by the latitudes. When we talk about this, we talk about a topographical map for columns of air. And when we refer to it on paper, we look at paper with topographical or contour lines on it. This is for the warm area of the warm column of air at 1,800 meters. It has its own contour line. Refer to it another way. We can go from a visualization of altitude to a one-dimensional method of showing altitude in an upper level map, but we make it a little bit easier for you to understand by laying it over a map of the US or of the world. And you can see your contour lines on the area of the US that you know well, around Baja. Obviously, the temperatures are going to be warmer there, and the altitudes of your 850 millibar plane are going to be higher. There's the 1,800. Up here by the cold is where you'd see about 1,200. In addition to that, we have to bring in the idea of troughs and ridges. Troughs are cold, dense air that is dense and pushing south in the northern hemisphere. Ridges are warm air pushing north in the northern hemisphere from the equator. These are ridges of warmer, less dense air, and troughs of colder, more dense air. That was an 850 millibar map. We could have a 500 millibar map, and we're going to be using 500 millibar maps quite a bit. You see, obviously, that the altitudes change. 500 millibars is far above 850 millibars of pressure. And so the altitudes that we're looking at are far above the altitudes that we were looking at in the past. We're up around 5,700 meters. Before we were around 1,500 meters. This is a 500 millibar map. The 500 millibar map has the same ridges and the same troughs. They are just at different temperatures. And the warm areas, because they are higher up in the atmosphere, are a lower temperature for warmth. And the trough areas, which represent the cold areas of the 500 millibar atmosphere, are obviously much colder. Key to remember, ridges are warm, troughs are cool. And these contour maps can look like have many different styles. Here's what's important in here. That on surface maps, everyone's at sea level. You can see the horizontal movement of air by looking at the isobar differences. But on upper level maps, everyone is at one pressure. There is one plane for 500 milligrams. 500 millibars. But there are different altitudes for 500 millibars. Generally, in the south, the altitudes are higher, and in the north, the altitudes are lower. One other summary. Remember, isobars are for surface maps. They connect points of the same pressure reading, or similar. They go in 4 millibar differentials. Contour lines are for upper level maps. They connect points with the same altitude at the same pressure. Review this. I hope it makes sense to you, and ask questions on the YouTube comments section if you have any. Thanks, and see you soon.